Hello and welcome to another exam paper walkthrough. We've got a studio audience today, which is quite interesting. We'll see how this goes. So today we're looking at the Pixi, they're calling them best guess papers, they're predicted papers. They're based on paper 1 being sat. They've taken all the topics that occurred on paper 1 and made a prediction for what's going to appear on paper 2 and paper 3. They've done 2 sets of these papers. I did the foundation version earlier today. Really nice papers, really good. So we'll see how this one plays out. So question 1, express 180 as a product of its prime factors. Glad this question has come up just because it gives me a good opportunity to show the factor button on your calculator if you're not familiar with it. Okay, so your calculator's got a really nice function where it will automatically break this into its product of its prime factors. So if you type the number in, you press shift, and then we've got, let me just spot it on this different model. We've got fact written above the time function button. I've done that wrong. So if I press equals and then I press shift and then that value, it will automatically break it down into its prime factors. So that's going to be 2 squared. So I'm just going to say that I'm going to write fact on my exam paper just to show anyone that's marking the paper. Anyone that's marking the paper, just that I've used the factor button, not just come up with the answers. So factor button on my calculator gives me the value 2 squared times by 3 squared times by 5. And we don't need to do a factor tree for that. We can just use that on a calculator paper. On a non-calc, you'd have to break it down, but on a calculator paper, you can just use that. Okay, question 2 says then, Martin thinks of 2 numbers. He says the highest common factor of my 2 numbers is 6. The lowest common multiple of my 2 numbers is 15. Write down 2 possible numbers that Martin could be thinking of. So if we were listing all the factors and putting them in a factor tree, the highest common factor of them is 6. And then they need to be a multiple of 12. So if I call that x and y for now, that's just going to be the section that's there and the section that's there. 6 times by x, 6xy needs to be a multiple of 15, so n times 15. So 6 isn't a factor of 15, so n can't be 1. There's going to be lots of options. The first number that I multiply 15 by to get a number that's a factor of 6 would be 2. So if I said n was equal to 2, then 6 times by xy would be equal to 2 times 15 would be equal to 30. So I'm looking for 2 numbers that multiply together to make 5. So arguably I could have 1 and 5. So my numbers could be 1 and 5. So my numbers could be 6 and 30. That would be the first pair that worked. You could have lots of other versions, but I'm going to go 6 and 30 for my first pair. Okay, question 2. On an activity day, students play sports. They play football or hockey or tennis. 120 students are on the activity day, 30, and then you're given information. So this is setting really up for a two-way table where we've got boys and girls, and then we've got the options of football, hockey and tennis. So I'm going to put a total and a total. In the end, I want to work out the number of girls who play tennis, girls that play tennis. So that's really the one that I'm trying to work out. I'm going to do it in stages though. I'm going to put information from the question. So 120 students are on the activity day. 30 of the students are boys. 12 of the boys and 26 of the girls play hockey. So hockey is 12 boys and 26 girls. 45 of the students play football. And 35 out of the 45 students who play football. So we didn't really need that piece of information because it's repeated there. 35 are girls. So from there I need to use, I'm going to fill in the rest of the values. So I'll do that as a second level. Let's go for purple for that. So we've got to have 90 there. And to be fair, we could work out the next part. 35 plus 26 is equal to 61. So 90 minus 61, 29. Don't need to do the full two-way table. Could fit in the other values, but there's no real... What I would do is in an exam, I would do it that far. Then at the end of the paper, I'd come back and fill the rest of that in if I've got time, because I can double check my values in the two-way table. But that's as far as I'd go. Okay, so yeah, I'd stop there. When I redo the paper, I'd come back and fill in the other values. So provided I've done that right, I'm going to get 10 as my value there. I would get 38 as my value there. That value then must be 8, and then I can double check that that equals 37 two ways by adding those two and by adding those two and taking it away from 120. But realistically, I probably wouldn't have gone. I would have just stopped at 29. Okay, question 3. So use a ruler and compass to construct the perpendicular bisector of the line segment AB. You must show all your construction lines. Not a very easy one to do on a PDF, so I'm going to just crop this into my snipping tool. So in theory, to do this, you need to get your protractor, your compass. My kind of makeshift compass is a circle. I'd put the point of the compass, put the compass on A. I need to make sure that my arms on my compass are bigger than halfway over the line. So I'm looking roughly 3/4. So that's the center of the circle is where my point of my protractor, point of my compass goes, and then my pencil would run around the outside. So I'm just going to arc there and arc there. And then keeping my compass arms the same distance apart, I put my compass point on B. I'm going to do the same from the opposite side. And then the 2 points where the compass lines overlap each other is the line that I'm going to use for my perpendicular bisector. So let's switch that for a ruler. And then if I draw a line between them, that becomes my perpendicular bisector. So that's how I would do perpendicular bisector of the line segment AB, and that's my construction line. My construction lines are these are arc lines here and here. Okay, question 4 then. So Gemma has the same number of sweets as Betty. Gemma gives 24 of her sweets to Betty. Betty now has 5 times as many sweets as Gemma. Work out the total number of sweets. Work out the total number of sweets that Gemma and Betty have. So if I start by putting this into a ratio, so Gemma and Betty at the start, they have the same number of sweets, so X and X. So start. Then after, Gemma gives 24 of her sweets to Betty, so Gemma's now got X minus 24, 24. And Betty's now got X plus 24. Betty now has 5 times as many sweets as Gemma. So that means that Betty's sweets, X plus 24, is equal to 5 lots of X minus 24. So if I cross multiply, if I tidy this up a bit, X plus 24 is equal to 5X minus 120. So then I'm going to take all my x's to one side, all my numbers to the other side. So 144 is going to be equal to 4x. And then in theory, I could solve for x at this point, but realistically, work out the total number of sweets that Gemma and Betty have. So I want to work out 2x. So 2x is going to be equal to half of that, so 72. Don't need to go any further than that. Okay, and question 5 then. So this diagram shows 4 triangles, so we've got the 4 triangles. 2 of these triangles are congruent. Write down the letters of the 2 triangles. This one's not a particularly obvious one. What I'm going to do is I'm going to add information. So if I added that was 55 plus 45 is 100, so that must be an 80-degree angle, which means I can also fill in the angle here as 55. It gives me a bit of a hint. So in theory, I'm looking for the 10 centimeter between a 55 and a 45 angle. Can't be this one. Can't be this one. And this one, 10 centimeter, 45 and a 55-degree angle. So it's got to be triangle A and D are the congruent triangles. Okay, right, 152 million in standard form. There is a way we can do this on our calculator if you're really struggling with standard form. So in effect, we're going to have 6 zeros. So if we want the decimal point there, we need 8. So 1.52 times by 10 to the 8. If you're particularly struggling with standard form and want a version of being able to do it on your calculator, if you type the number in 152 million 1 2 3 4 5 6 and you want your calculator to convert that to standard form, you can press shift setup. You want the number format to be in scientific or SCI mode, and you want the number of decimal places, you want 2 decimal places. So if I press equals now, that will automatically convert it into standard form. And I've done that slightly wrong. So what I actually wanted was 3 significant figures. So what I've done. So if I go shift menu, number format, scientific, and I want 3 digits to be shown, that gives it me in standard form. I don't recommend this very often because now that it's in this mode, every answer that I type in will give it me in standard form to that number of significant figures. So easiest way to get that back to normal is shift reset 3 equals AC, and that just resets my calculator. So write this as an ordinary number, 2.4 times 10 to the minus 3. In effect, that's going to add 3 zeros, so 0.0024. I'm just, if I type that in, just checking in my head, we can. So that's not overly helpful. I was just wondering whether I could convert the opposite way around. No, I don't think I can. So that's my standard form question. Okay then, question 7. So shop sells packets of black pens, red pens, green pens. There are 2, 5, 6 on Monday, and we're given some information. The ratio of packs that were sold in the ratio black to red to green was 7 to 3 to 4. There were a total of 212 pens sold. Work out the number that are green. So the first thing I'm going to look at is actually this is packs. If we look at actual number of pens, I'd need to times this one by 2, this one by 5, this one by 6. So I'd have 14 to 15 to 24, and I want to split 212 in that ratio. So my total number of parts is going to be 14 plus 15 plus 24. So I've got a total of 52 parts. So if I divide that by 53, so that's going to be 41. So 512 divided by that answer gives me 4. So it goes in exactly 4 times. So the number of green pens is going to be 24 times by 4. We're going to have 96 green pens. Okay, and on to question 8. Tarek buys a laptop. He gets a discount of 5% off the normal price. Tarek pays £551 for the laptop. Work out the normal price of the laptop. Again, I'm going to show you, just because we're prepping for the calculator paper, I'm going to show you the ratio function on your calculator that will do this for you. So if he gets a laptop discount of 5%, then he's only paying 95% of it. So if we kind of do this, 95% of the amount is 551. We want to find 100%. So the ratio function on your calculator can do this. So ratio mode is 4. And then if you think about it, we've got 2 ratios at the moment. We've got 95 and 551. We know 100. Well, we want to find 100, and we want the value here. So our mystery value is the x. So we want the second function of the ratio. And then we're going to type it in 95. We know that 95 is equivalent to £551. And we want to find 100. So 580. So that's how you can use the ratio function on your calculator. If you don't want to learn the ratio function on your calculator, which is perfectly acceptable at this point, we're going to have to do 551 divided by 0.95, which is in effect what your calculator will do in the background, but 551 divided by 0.95, 580. Don't invest £6,000 in a savings account. The savings account pays compound interest at a rate of 2.4% for the first year, 1.7% for the extra years. Work out the value of John's investment at the end of 3 years. So in effect, 2.4% as a multiplier is 1.024, and then 1.7% would be a multiplier of 1.017. We want 2 lots of that, so it would be squared. So to work out this as a single calculation, it would be 6,000 times by 1.026 times by 1.017 squared. So 6,000 times by 1.026 times by 1.017. Sorry, I've mistyped, haven't I? Yeah. Misread my own writing. Let me just finish with the squared though. So we're looking at 6,354.6716 ... So when I round that to, does it tell me? Doesn't tell me what to round it to. So I'm going to go pounds and pence. So £6,354 and 67 pence. Okay, question 9 then. So ABC are points on the circumference of a circle. Centre O, ADE is the tangent to the circle. Angle BAE is 56 degrees. Angle CBO is 35 degrees. Work out the size of the angle CAO. So CAO. So I want this angle here. Okay, so I'm going to do this in hopefully a logical way. So what I'm going to say is this angle here would also be 56 because it is the alternate angle, alternate segment theorem. So I'm going to say that BCA is equal to 56, and the reason is that it's an alternate segment, or from alternate segment. Theorem. I'm then going to say that this angle here then is going to be twice that. So BOA is going to be equal to 56 times by 2, which is going to be 112 degrees. And the reason for that is angle at center is twice angle at circumference. My next part is slightly up to you how you do it. So I now know that that angle there is 112. There's going to be a real common way of finding out this angle, these angles, because they're the base angles of an isosceles triangle. And then from there we can work out the size of this angle. I'm not a massive fan of that method. What I'm going to say is, I'll change pen colour just to show that this is probably an awkward way of doing it. I'm going to find out the size of that reflex angle, and then say that angles in a quadrilateral add up to 360. I think that's an easier way of doing it. So the obtuse version, the reflex angle of BOA is going to be equal to 360 minus 112. So 360 minus 112, 248 degrees, and that's angles at a point. Equal 360. And then I'm going to say that the angle that we're after, which is OAC, so OAC is going to be equal to 360 minus the angles that we know, so 248, 56, and there was one other, is it shown on the diagram? 35. So 360 minus the answer that I just worked out, minus 56, minus, and I've not written that down right, 35. Gives me 21. And I've missed that reason, so angles in a quadrilateral that's not right. Quadrilateral equal 360 degrees. So not set out particularly clearly. My dyslexia, I'm not very good at setting these out, but I always do my working and then explain my reason in brackets to the side, and that works pretty well for me. Okay then, question 10. A car travels for 18 minutes at an average speed of 72 kilometers per hour. How far will the car travel in these 18 minutes? Again, I'm going to show you a kind of something useful on your calculator for this one. So our issue is we've got minutes and we've got hours. So we need to convert one in theory. Generally speaking, distance is going to be equal to, well, speed is equal to distance divided by time. So distance is going to be equal to speed times by time. What I'm going to do is I'm going to work out the time in terms of minutes, and so I can use this time function on my calculator to convert 18 minutes into hours quite easily. If I type in 0 hours and 18 minutes, that will automatically give me what fraction of, well, what what decimal of an hour it is. So the time button on your calculator is a real quick way of converting between minutes and hours. So I'm going to do speed, which is 72 times by 0.3. So it just times that by 72 gives me, and I want it, so something's gone slightly wrong. Let me just type in that again. So 18 minutes is going to be 0 hours and 18 minutes. So as a decimal, that's going to be 3/10, and I want to times that by 72. So times by 72 gives me 21.6. No, I was right the first time, 21.6. So 21.6 kilometers. And that time function on your calculator, I'm sure that you're more than capable of doing it without the time function. It's just quite a nice little shortcut. And particularly for that question, 18 minutes is 18 out of 60. So you could work out that decimal anyway. Okay, second part of that question. So David says 72 kilometers per hour is faster than 20 meters per second. Is David correct? Show how you got your answer. So if I look at 72 kilometers per hour, and I'm just going to look at the kilometers per hour. So kilometers per hour, so 1 kilometer per hour. If I wanted to convert that into meters per second, to get from kilometers to meters, I would need times by 1,000. To get from hours to seconds, I would need times by 60, times by 60. So in effect, I can take this 72 times by 1,000 over 60 times 60. And that will convert it into meters per second for me. So 72 times by 1,000 over 60 times 60 gives me 20. So 72 kilometers per hour is equal to 20 meters per second. So David has said it's faster. Is David correct? No, it is equal. Okay, question 11. We're asked to draw a cumulative frequency graph. Complete the table first of all. So 5, and then 5 plus 18 will be 23. 23 plus 12 would be 35. 35 plus 4 would be 39. And then 39 plus 1 would be 40. On the grid, draw the cumulative frequency for the graph from your table. So each point goes at the maximum of each group. So I'm looking at plotting, I've just lost my top value. I'm looking at plotting 5 at 175, so that would be my first cross. Then I'm looking at 180 and 23. Then I'm looking at 185 and 33. Then I'm looking at 190 and 39, and then finally 195 and 40. So you're not really going to, I'm sure you wouldn't lose a mark, but I would never join this to 0, 0, because I don't know that there's no one less than 170. So this is the type of cumulative frequency that I wouldn't join to the origin. That's not a very smooth curve, but that's kind of the idea. You'll draw a smooth curve. And in part C, find an estimate for the number of plants with a height greater than 787. So an estimate for the number of plants. So 187, find 187 on my graph, which is going to be there. So from there, I would go up until I hit my graph, a ruler out, and then from there, I go across to read. So I'm making that 36, so I've got 4. Okay, question 12. Frustrum, so that's cone with the top chopped off, is made from removing a small cone from the height from a large cone as shown in the diagram. The frustrum is made from glass. The glass has a density of 2.5 grams per centimetre cubed. Work out the mass of the frustrum. Give your answer to an appropriate degree of accuracy. So we need to work out the volume of the frustrum. We're given a lot of students will struggle with the first step of this. So in effect, let's draw back and just view the two front elevations of the top cone. Would be a triangle. And then what I'm struggling to, well, not struggling, what I need to work out is the height, what I need to work out this radius here, or this diameter. I'll call it diameter for now. So currently I've got a diameter there, I've got 12 there, I've got a total height of the cone of 15, and then the height of the bit that's chopped off is 5. So there's a scale factor of 3. The top cone is 3 times, the larger cone is 3 times the size of the smaller cone. So if that value there is 12, then this value here would be 12 divided by 3. So that would have a diameter of 4. So the diameter is going to be 12 divided by 3, which would be 4. From there I can work out the volume of the frustrum. So the volume of the frustrum is going to be the volume of the larger one, which would be 1/3 of pi times by the radius, which is going to be 6, squared times by the height of the full cone, which would have been 15. From that I need to subtract the volume of the smaller cone, which would be 1/3 times by pi times by the radius would be 2 squared times by the height, which would be 5. And I would not really bother with anything other than typing that into my calculator. So I want to do 1/3 times by pi times by 6 squared times by the height minus 1/3 times by pi times by 2 squared times by 5. So I'm going to leave it like that for now. So 520 over 3 pi. That's the volume of the frustrum. So if I'm told that the formula that I remember is density is equal to mass divided by volume. So if I want to work out the mass, I'm going to do the density times by the volume. So for this shape, the mass is going to be equal to 2.5 times by the volume, 520 over 3 times by pi, which is going to be equal to that times by 2.5. So I'm making it 1,300 over 3 pi, which as a decimal is going to be equal to 1,361.356817. I'm going to go appropriate degree of accuracy. I'm going to go 2 decimal places. I'm sure that would be, my argument would be, that's one significant figure greater than the information in the question. So I would go 1,361.36 grams. I can see a few arguments why I've gone more accurate than I needed or should have, but I always go 1 degree more accurate than the question. But I either do that based on significant figures or decimal places. If I was going in terms of significant figures, 2 significant figures is the greatest degree of accuracy, so you could argue that I've gone far too accurate. But that would be my value. Okay, question 13. The table gives some information about the weight in kilograms of 50 suitcases at an airport check-in desk. Work out an estimate for the mean weight. So for this, I'm going to have to take my mid values. So I'll write it as a list. So I'm going to do 5 times by 16 plus the midpoint of 10 and 15 is 12.5. It's just a bit of an awkward one. Times by 18 plus 17.5 times by 10 plus 20. Middle of this group is going to be equal to 27.5, I think. 27.5 times by 6. Then I want to divide that by the total frequency, which is going to be told to us there, but double check. 16, 34, 44, 50. Yeah, divided by 50. I tend to just type it into my calculator like that. So fraction button, 5 times by 16 plus 12.5 times by 18 plus 17.5 times by 10 plus 27.5 times by 6. And I'm dividing that by 50. So that gives me 12.9. Okay, passengers have to pay extra money for any suitcases that weighs more than 20 kilograms. Work out that 2 of the 50 suitcases are chosen at random. Work out the probability that both suitcases weigh more than 20 kilograms. So suitcases that weigh more than 20 kilograms, we've only got 6. The probability of picking a suitcase the first time would be 6 out of 50. The probability of picking it the second time would be 5 out of 49. So my my total probability for this question is going to be 6 out of 50, which we could cancel, but no benefit, times by 5 out of 49. Have I put 49 in the right place? There we go. So 3 out of 245. Could go decimal. I'm sure that would be more than acceptable, but fraction is probably the better of the answer there. Just trying to make that look like a 5 rather than a 2. I'm not doing a very good job of it. And part C, on the grid, draw a histogram for the information in the table. So for my histogram, I need to work out the frequency density. So I'm going to bring in another column here called FD, frequency density. So we've got a group width of 10, group width of 5, group width of 5, group width of 15. So my frequency density is frequency divided by the class width. So that's going to be 1.6. That's going to be 18 divided by 5 is going to give me 3.6. That's going to give me 2. And then 6 divided by 15 is going to be 0.4. 6 divided by 15 is going to give me, 0.4. So I need to plot that on a histogram. So my histogram needs to go up to a maximum height of 3.6. Let's see how much space I've got. Right. So I struggled a little bit seeing these. So I'm going to call that 1. I'm going to call that 2. Doesn't show very well on my screen. 3. And I'm going to call that 4. Right, so my first group going from 0 to 10 is going to be 1.6, which is going to be there. So I'm just going to kind of plan the sketching of it before I actually go to my ruler. My next one is going to be 10 to 15, which is going to be 3.6. So I'm going to say that's there to there. My next one is going to be 115 to 20, and that's going to be at 2. And then my final one is going to be 0.4, which will be there. 20 to 35, so we're going to there. Right, now I'm going to make that into my actual graph. Oops. That's all my horizontal vertical lines. Add my horizontals. Okay. I've drawn that the wrong place. Okay, and that's my histogram. No complicated question on the back of that, so that's nice. Okay, question 14. Here are the first 5 terms of a sequence. Find an expression for the nth term of the sequence. So let's look. We haven't got even gaps, so we're assuming that it's going to be a quadratic sequence. So to help me out, I'm going to give myself a bit more room to set it out. 4, 11, 22, 37, and 56. So my differences, my first set of differences are, let's do these in different colours. So my first set of differences are 7, 10, 15, so I've messed up there. That was 11, my mistake. And then difference between those is 19. That's my first set of differences. We can see that they're going up. It's looking promising. So let's go for my second set of differences. We'll go purple for this. So my second set of differences are 4, 4, and 4. So that implies that I would have a half of this value n squared. So I'm going to have 2n squared somewhere in my sequence. So if n is 1, 2n squared would be 2, 8, 9, 18, 4, 16, 32, and 25, 50. So I then look at what I need to add on to my sequence to get to this. So the difference is 2, 3, 4, 5, and 6. And if I'm describing this sequence, the difference, keep catching that with my finger, I'm describing that as n plus 1. So my total sequence is going to be n squared, sorry, 2n squared plus n plus 1. Okay, question 15. Nice looking question straight away. So we're looking at quite a crowded bearings question. Diagram shows the position of 3 towns: Acton, Barnston, and Chorlton. I'll call them A, B, and C from now on. B is 8 kilometers on a bearing of 037. C is on a bearing of 9. is 9 for the bearing of 150. Find the bearing of C from A. So I want this. I'm going to add that to my diagram. So I want this angle here. So I'm going to call that X for now. Okay, so how am I going to go about doing that? Right, well, I'm going to say that, just planning it in my head. Okay, so I'm going to work out this angle here. So this angle here is going to be equal to, this angle here would be supplementary angle, so that's going to be 143. So based on that, that internal angle is going to be equal to 360 minus 150 minus 143. So that, I've missed out my minus. So that angle there is going to be 67. Right. And I don't think I can work out any of the other angles just yet, which is frustrating. Because I can't find a straight route where I use advanced trig just once. So I think I'm going to have to use it twice, which is a bit of a pain. But we'll do that. So it leaves nicely for the cosine rule to work out this length. So I'll call that length y, and then I can use the sine rule to find out x. So if I start with y, so my sine rule is going to be a squared is going to be equal to b squared plus c squared minus 2bc cos a. So that's going to be 8 squared plus 9 squared minus 2 times 8 times 9 times cos of 67. And at this point, I'm also going to kind of do my other part. So I'm going to say that following the sine rule, sine x over 9 is going to be equal to sine of 67 over y. So sine x is going to be equal to 9 lots of sine 67 divided by y. And I'll come back, loop back around to this. So 8 squared plus 9 squared minus 2 times 8 times 9 times cos of 67 is going to be equal to that value. So I'm going to jump straight to the square root of that. So the square root of that is going to be equal to 9.4199 dot dot dot. So then I'm going to substitute that in here, and I'm just going to go x is going to be equal to shift sine, so the inverse of sine, I'm going to type it in as a fraction, 9 times by sine of 67, and I'm going to divide that by the answer I just worked out, close my brackets up, so that gives me the value of 61.5786 dot dot dot. So that's going to be the size of angle x, but we want the bearing, so to that I'm going to say that the bearing is going to be x plus, just saw it and then forgot it, 37. So that's going to be equal to that plus 37. It's going to be equal to 98.5786 dot dot dot. So to one decimal place, I'd slightly argue this bearing should be three figures, so that should be 098, but we'll go 098.6. So that's going to be my bearing. Right. So question 16 then. show that 2x cubed plus 4x is equal to 3 has a solution between 0 and 1. So if x is equal, the way that we do this, I did this recently with my year 11s. We need to say when x is equal to 0, 2x 2 times 0 squared would be 2, plus 4 times 0 is 0, so that's going to be equal to 2. When x is equal to 1, 2 times 1 cubed is going to be 2, 4 times 1 is going to be 4, so that's going to be equal to 6. So the solution lies between 0 and 1. So in effect, we said when x is 0, it's too small, it's less than 3, which is less than 3. When x is 1, it's greater than 3. So the solution must lie between 0 and 1. Next bit, show that it can be rearranged. So we're priming ourselves for the iterative formula. So if I just look at how we've rearranged it, so they've rearranged it with still an x cubed in, so in effect we're rearranging. I'm going to rearrange to make that the subject. So to do that, I'm going to minus 2x cubed from both sides, so minus 2x cubed from both sides, so that's going to be 4x is equal to 3 minus 2x cubed. If I then divide both sides by 4, and I'm going to split them into two parts, so x is going to be equal to 3 divided by 4 minus 2x cubed divided by 4, so the 2's would cancel, so that would be x cubed over 2, which is what you are asked to show. So starting with x is equal to 0, use the iterative formula to find an estimate for the solution. So I think that there's a word missing from this solution. So start with x is equal to 0, use the iterative formula times, and there should be a value there. So it's normally 3 or 4 times. We'll say 4 times, although I would imagine it was less than 4. So A level you can say to an approximate degree, but we're not going to do that. We're going to do it 4 times. So on my calculator, the way that I would do this is I'm going to type in 0 as my first value. So I'm going to just go x0, x1, x2, x3, and I'll do x4 as well. I think the question's probably 3 times, but we'll go 4 times just for good measure. So we start with 0. So I've got 0 in my calculator function as my last answer. I'm then going to type in 2 times by my last answer cubed. No, sorry. I'm using the wrong thing there. So I'm typing this in. So 3/4 plus, sorry, not plus, minus my last value cubed over 2. So every time I press equals, I'll get my next value in my iterative formula. So the first time I get 3 over 4. My next value is 69 over 128. My next value is 0.67167 ... And then my next value is 0.5984 ... So we're going to go. I always debate on this. Having done A level, I kind of debate. So it's going to say to an appropriate degree of accuracy. So it's going to be one of these two values, depending on whether it wanted us to do it 3 times or 4 times. Let's say 4 times. So 0.598482258. but I would argue I'll just show you this. It's not particularly relevant to this question. Currently, these don't round to the same number. So to go more accurate, every time you press equals, you get more and more accurate. So realistically, it's going to be closer to 0.62 or 0.63. The more accurate I go, but I'm going to go for that value, just having done it 4 times. Okay, so we've got vectors question coming up here. Let's have a look at this. Okay, so we've got a quadrilateral. We're told that C to A, and we've got the information, all the information drawn in. C to A is 3A, C to B is 6B, and B to Y is 5A minus B. X is the point on AB such that it splits it in the ratio 1 to 2. So let's just approximately draw it there for now. Prove that C to X is equal to 2/5 C to Y. C to X and C to Y. Okay, interesting. Right. Okay, so I'm going to say that C to X is going to be equal to C to A followed by A to X. Right, so and we know C to A is 3A, and A to X is going to be 1/3 of A to B, so that's going to be minus 3A plus 6B. So let's tidy this up a little bit. So 1/3 of minus 3 is going to be minus 1, so that's going to be 2A, and then 1/3 of 6B is going to be 2B. And I'm going to stop there for now, I think. Okay, and I'm going to say that C to Y, and I might come and simplify this in a moment. So C to Y, I'm going to go this route, C to Y. So that's going to be 6B plus 5A minus B. So that's going to be 5A plus 5A plus 5B. Okay, interesting phrasing on this question then. So what I'm going to then do is I'm going to take out a factor of 2/5 from this, just to put it in the format that I want it. So if I take a factor of 2/5 out there, that would give me 2A plus 2B. So if you think about multiplying that out, that would give me no, I'm not going to take that factor out of there. I'm going to do the same thing, but what I'm actually going to do is I'm going to take the factor out here. So I'm going to say that that is what I'm actually going to do is I'm going to factorise both of them. So I'm going to say that that is 2 lots of A plus B, and I'm going to say that that is 5 lots of A plus B. So they're not equal, but we've got the same part there. So in effect, I can say that CX is going to be equal to 2/5. So I'm going to change this slightly just to make it easier to explain. So from here, that means then that CX over 2 is going to be equal to A plus B. And then this is going to say that so 5 CY, no, CX over 5, CY over 5 is going to be equal to A plus B. We can then put them equal to each other, so we can say that CX over 2 is going to be equal to CY over 5. So CX is going to be equal to 2/5 of CY. And I hope that's what we were asked to show. Yeah, that's what we were asked to show. So there we go, that's worked through nicely. Okay, and then the final question. So cars moving from rest. Graph shows information about the speed. So we've got a speed time graph. Calculate an estimate for the gradient at 15. So at 15, we need to create a tangent to the curve. So line just touches, I'm going to call that my line. And then we need to work out the gradient of that line. So I'm going to pick values that I like. So I'm going to make a fairly large triangle. So I'm going to make that as my triangle. And I need to work out the gradient of that line to work out the gradient, an estimate for the gradient. So we've gone from what looks like 7 up to what looks like 23.5. So I'm going to say that that is, let's get my calculator out. So I've gone from 23.5 minus 7 is a fair approximation. So I've gone 16.5 up, and then across I've gone 22.5. So my gradient, my estimate from the gradient is going to be equal to 16.5 divided by 22.5. So I'm estimating my gradient at 0.73. And you could have a similar value. I think anything acceptable would be plus or minus a couple on this one. So I'd say anything between, let's say 6 and 9, 0.6 and 0.9 would be okay, I'm sure. Okay, part B, describe the relation. Describe what your answer to part I represents. So it is going to be, it's a unit of speed divided by time, so that's going to be the acceleration. So it would be the acceleration. try and write that readably. So accelerate. So it's going to be the acceleration. Work out an estimate for the distance the car travels in the first 20 seconds. So first 20 seconds. So these questions, this is a version of the trapezium rule. So I'm going to split it into 4 trapeziums. And then I'm going to work out the area of each trapezium, or triangle for the first one. And then that's going to be my value. So I really want to be able to see my graph at the same time as writing. So distance is going to be equal to the first triangle, which is a half of A times B. So we're looking at 5 times by 4 plus a half of, and then we need to find these two values. So we're looking at 4 and 12. So half of 4 plus 12 times by 5 again, plus a half of 12 plus the height of this one is looking like 18 times by 5 plus half of the final one, which is going to be 18 plus 20. Times by 5. Okay, and I provided I typed that in okay. I'm not going to have any dramas with that. What I'm actually going to do is I'm going to take a bit of a shortcut. I'm going to take the half, just to type it in a bit easier for myself, times by 5. I'm going to take that out as a common factor. That would leave me with just 4 plus 4 plus 12 is going to be 18, plus 12 plus 18 is going to be 30, plus 18 plus 20 is going to be 38. So I'm looking at 225. Double checking some of these values. So I've misadded that one value there. 12 plus 18 is going to be 40, not 20. So I'll make it 200. Feel like I've made a mistake there. 4 plus, that should have been 16. There's a mistake. 12 plus was 30. Let's try that one. There we go. 220 meters. So 220 meters. Okay, and that brings us to the end of this paper. Really nice paper. Last few questions were really nice and challenging. Good paper, really great paper from PixiMaths. Really like that. So thank you very much to them for producing it. Please do check out their website. It's a great site. Some really useful topics. When I put this video up, I will chapter it by the content of each question. So if you're stuck on a particular area, you can find out the topic related to that either by looking at the description in the channel or the chapters of the channel. Thank you very much for your time, and good luck with your exams. Feel free to type any questions or comments in the chat.